calculations. Okay, so now I'm ready to go on to my velocity calculations. So I'm going to go ahead and move this paper aside, but I'm going to leave it here in the frame, just this left part here, so you guys can see what we're doing and how it connects to the plot that we just did, that we already did, right? So we can really focus on how to get from here to our velocity calculations. So I'm going to go ahead and switch to a different color. Let's use black for this one. So we are going to calculate average velocity. So the first thing that we want to do is look to see how many straight line segments we had in our position versus time graph, right? Here we have 3 different slopes in the graph. We have 3 different lines, each with its own slope. So we're going to have to do 3 calculations. Okay. Now the first calculation is going to happen from T0 to T1, second from T1 to T2, third from T2 to TF. So I find it helpful to make a space for 3 separate calculations. So I'm going to go ahead and put my finger right here, draw a line to kind of divvy out the space for each calculation. Now on your worksheet, you guys already had the split up for you. So even if you didn't realize that at first that you had to do 3 velocity calculations, you still were given in that worksheet just a hint as to how to approach that. So once you've got figured out how many different lines that you have to calculate average velocity for, then the first thing that you want to do is go ahead and write down the times for that. So the first time range is going to be from T0. Let me switch to a different marker because this one is not working out. I'm going to go ahead and switch back to my blue marker. So T0 is equal to 0 seconds. So from T0 equals 0 seconds to T1 equal to 3 seconds. Okay. Our second calculation is going to be from T1, so this little line segment right here, from T1 equal to 3 seconds to T2, which is equal to 4 seconds. And then our last calculation is going to be from T2 to TF. So from T2 equal 4 seconds to TF, which is equal to 6 seconds. Okay. So I'm going to go ahead and draw a little line right here. Now, somewhere on your paper, you want to write down what the X values are as well. We already have what the T values are, the time values are, but we also want to make sure that we write down the positions as well. And we have them right down here, right below our position graph. So I'm going to go ahead and write these down here before we proceed with any calculations. So X0 is equal to -4 meters. X1 is equal to +2 meters. And then you might ask yourself, well, how do I know which X's, which positions I need to use for each calculation? So just go back, look and see what times you picked out. Go back to those 2 ordered pairs. You should only have 2 ordered pairs that you care about for each calculation, and you can cover the other ones up if that helps you. You need X0 and X1. So that's why I wrote X0 and X1 for this one. The next 2, we're only going to need T1 and T2. So we only need to write down those positions and then so on. So right here, I'm going to write down X1 equal to +2 meters. X2 is equal to +2 meters as well. Right down here, X2 is equal to +2 meters. And finally, XF is equal to +4 meters. So you see there's some overlap, right? Because these line segments overlap at the ends. So now it's helpful to remind ourselves what that average velocity equation is. So I'm going to go ahead and write it up here in a different color as well so that it stands out a little bit. So average velocity is equal to the change in position over the change in time. And as it happens, that breaks down into the top part of this equation, the final position minus the initial position, so xf minus x0. And then below that, on the bottom part of the fraction, it's going to be tf minus t0. In other words, the final time minus the initial time. Keep in mind that when this says final time and initial time, final position, initial position, it means the final time for that time range. So for this first section of the graph where we're going to calculate the average velocity, the initial time is t0, but the final time is t1. So that means that yes, x0 is still x0, but the final position that we need to worry about in this case is going to be x1, not xf, because we're not worried about the position over here. We're worried about the position right here at the end of this line segment. So I'm going to go ahead and start filling this out. So v is equal to, and if it helps you, just draw a straight line. You can throw in some minus signs and then put your numbers in one at a time. So xf, in this case, the final position, is positive 2 meters. The initial position was negative 4 meters. I'm going to do a parentheses right here because we've got a double negative. And then tf is going to be 3 seconds minus that initial time, 0 seconds. So that gives us positive 2 meters plus 4 meters, because negative times negative is a positive, divided by 3 seconds, which is equal to 6 meters divided by 3 seconds. So our final answer is 2 meters per second. So I'm going to go ahead and circle that. So remember, in class we circle our final answer, we block it to make it stand out so that we know, okay, this is the information that we need moving forward. And then we're going to repeat that calculation with these other two. So for the second line segment, the velocity is equal to, and again, I can draw a little horizontal line, my negatives thrown in there so I can set it up. My final position for the second line segment is positive 2 meters minus positive 2 meters. That was my initial position. Final time is 4 seconds. That's T2. My initial time is T1, 3 seconds. So here you notice that my displacement was 0 meters. And that makes sense because it stayed at 2 meters the entire time, right? So that means that we have a velocity, an average velocity of 0 meters per second for the second calculation. Now moving on to the third one, we have velocity is equal to, and again, go ahead and set that up. Makes it a little easier for us. The final position is positive 4 meters minus positive 2 meters. The final time in this segment is 6 seconds. The initial time in this segment is 4 seconds. So that gives us 2 meters divided by 2 seconds. So our final velocity here is going to be 1 meter per second.